Hi and Assalamualaikum everyone. So today, me and my partner will be presenting about an article review about an IoT-based smart waste management system. The articles will explain about how IoT and sensors can make waste collection more efficient by monitoring bin levels in real life. And I will briefly share about this article review. That we will review one main article and make a comparison with another two supporting article. So this article review will be presented by me myself, Adila Nurmanisha binti Jalaluddin, and my partner Nurhafina binti Rohaifizan. So now for this article review, the main article we have been choose is a paper titled "An Intelligent Waste Management Application Using IoT and a Genetic Algorithm Fuzzy Interference System." This research was conducted by Sumaya Tasin Ikram, Vanita Mohan Raj, Sakival Ramachandran, and N. Barasu Balakrishnan, and published in the International Journal of Emerging Technologies in Computer Science and Electronics, IJETCSE. So the paper focuses on solving three main issues in waste management, which is inefficient waste collection in urban areas, poor sanitation and environmental pollution caused by unmanaged waste, lack of automation and intelligent decision making in existing system. So the proposed solution combines IoT sensors with a genetic algorithm fuzzy interference system to make waste collection smarter and more efficient.
Yang aku punya beg dia bosok.
Okay, tak bukan. So based on this article, the authors outline three main challenges, which is the first one. The article aims to automatically collect and analyze waste data. This means the system will detect the waste level in real time without needing manual checking. Secondly, the article want to reduce operational costs, human effort, and system error. By using automation and sensors, the waste management process becomes more efficient and less dependent on manual work. Finally, this article aims to optimize collection routes and decisions. Instead of following a fixed schedule, the system will suggest the best route and timing based on actual waste levels, saving time and fuel. So basically, these objectives help create a smarter, more efficient, and cost-effective waste management system. In this article, also we identified several key challenges, which is the first one: waste optimization is difficult, and manual waste classification is inefficient and labor intensive. Workers still need to check the bins manually, which takes time and increase workload. So secondly, many previous systems lack accuracy and robustness. They often fail to detect waste levels correctly, especially in real environments with noise, weather, or mixed waste types. Thirdly, the traditional waste management system is inefficient. Waste is collected based on a fixed schedule, not based on actual waste level. This leads to unnecessary trips and higher operational costs. And lastly, the traditional genetic algorithm (GA) has a major issue, which is it sometimes get stuck at a suboptimal solution, meaning it cannot always find the most efficient routes or decision. This system consists of three main parts, which is hardware and software, communication and sensors. So for hardware and software, in this research, they use the Arduino Uno board as the main controller, along with the HX711 load cell amplifier module, a servo motor, a breadboard, and junction cables. The software includes a GA Fuzzy interference system, cloud middleware, and an open IoT platform. Firmware and rules are uploaded into the Arduino. The cloud platform supports smart system decision making, user login and authentication, as well as warning generation. So next for communication, The system use the bulk Wi-Fi module for cloud-based communication. It allows web page tracking, alerts, and integration with an Android or mobile application. There is also potential use of RFID for additional identification features. And lastly, for sensors, we use an ultrasonic sensors to detect the distance or field level of the beam, and a lot cell with the HX711 amplifier to measure the waste weight. So basically, the combination of hardware, sensors, communication module, and intelligent software enable the smart bin to operate efficiently by monitoring waste levels and notifying authorities automatically. So next, we will talk about the system architecture and findings. So as you can see, this is the data flow of the system. Okay, we start from sensors, Arduino Uno, GAFIS, Wi-Fi, cloud and user interface. So this main article have a weaknesses. Basically, it have a weaknesses, which is from this research, this system has no large scale routing optimization. It is a limited hardware prototype, no AI or intelligent decision model, but um, it show the best result actually. As you can see, the performance result, the accuracy of the system is 95.44%. The precision is 96.68%, and it recall is 93.96%.
For this slide, I will briefly introduce the two supporting articles. The first article is titled IoT-based Intelligent Waste Management System, and the second article is titled IoT-based Smart Waste Bin Monitoring and Municipal Solid Waste Management System for Smart Cities. Okay, next I will go through the hardware and the sensor components used in all three articles. In the main articles, the system used an Arduino Uno together with the ultrasonic sensor and load cell connected to the HX711 module. This allows the device to measure waste H and waste weight, and a servo motor is included for the automated mechanism. In Article 1, the setup is more minimal. It mainly uses an Arduino and a Wi-Fi module. The hardware is simpler because this study is focused more on optimizing the algorithm rather than building a full physical prototype. Meanwhile, Article 2 uses the most complete hardware arrangement. It includes ultrasonic and IR sensor, a load cell with HX711, temperature and humidity sensor, a flame sensor plus GSM, GPS and RFID modules. This combination enables the system to operate effectively in real city and environment. For this slide, I will explain how each article handles communication and data processing. In the main article, the system communicates using a Wi-Fi module and processes the data through a GA fuzzy interference system. This allows the model to make smart decisions such as classifying waste level and controlling action automatically. The data is also sent to cloud middleware for further analytics. In Article 1, the focus is mainly on the optimization algorithm. The author used AHA for clustering, MOAHA for routing, and KNN combined with a AHA to correct missing data. This algorithm improves accuracy and efficiency, but the communication setup is still Wi-Fi based and tests mostly in simulation. For Article 2, the system combines GSM or GPRS and Wi-Fi for communication and store data in MySQL database. This study also includes forecasting of waste volume. And since it was tested in a real city, the communication setup is designed to handle real-world conditions. Now, I will explain the improvement part, where I compare the main article with the Article 1 and Article 2. Starting with the main article, the system integrates IoT hardware, AI optimization using genetic algorithm, and fuzzy interference logic, which make it both intelligent and practical. It performs real-time monitoring, classification, and decision-making with 95.44% accuracy, and it's also computationally fast, taking only 3 to 10 seconds. This means the system doesn't just collect data, it can also analyze and respond automatically. So overall, the main article provides a complete and automated solution combining both hardware and intelligent processing. Next, Article 1 focus mainly on algorithm optimization using artificial hummingbird algorithm AHA and k-nearest neighbor KNN to handle missing data and find efficient truck routes for waste collection. It is strong in computational performance, showing that it can save energy, time, and cost in simulation. However, this article was only tested in simulation environment without using any real sensor or hardware. That means the system is very strong in theory but less practical for real-world use since there's no prototype or real-time testing. Then Article 2 use multiple sensors including ultrasonic, temperature, humidity, and flame sensor for real-time waste monitoring and fire detection. It was tested in Najran City with 98% prediction accuracy, which proved that the system worked well in real conditions. This article is practical and effective for monitoring and predicting waste level, but its main limitation is that it's focused only on monitoring and forecasting, not on AI-based automation or decision-making. So even though it is stable and accurate, it doesn't include advanced AI features like route optimization or smart classification. In summary, Article 1 is strong in theoretical algorithm, Article 2 is strong in practical monitoring, but the main article combines both. It has real IoT hardware, artificial intelligence optimization, and full automation. That's why the main article produced the most complete, intelligent, and practical system among all three studies. These are references for the main article, Article 1, and Article 2. Okay, that's all from us. Thank you.